so welcome to the last unit of Algebra 3. I bet that's pretty exciting. We're going to start by looking at sequences. Okay, this is a sequences and series unit. There is a difference between a sequence and a series, but we're going to start with sequences. And there's two different types of sequences. So we have an infinite sequence, which is kind of exactly what it says. Now a sequence, I guess, would be a good thing to talk about first. So a sequence itself is just, it's kind of what the...
Debbie Willows and Matt Webb, would you please
it's kind of what the word
532, Debbie Willows and Matt
implies.
Webb,
okay, so when you talk about a sequence, okay, it's going to be some pattern of numbers. Okay, it's some kind of pattern of numbers. So like 2, 4, 6, 8, there's a pattern. We're going up by 2. It's a sequence. It's not just a random set of numbers. It actually has a pattern to it. And so that's a sequence. Now an infinite sequence means that it would go on forever. So we would include a little dot, dot, dot here at the end. We obviously can't write infinitely. Okay, we'd be writing for the rest of our lives. But I can show a little dot, dot, dot to say that it continues in this pattern for as long as, forever, for as long as we could possibly write it. So 2, 4, 6, 8. After that would come 10, 12, 14, 16, 18, so on and so forth. It does say the domain is a set of natural numbers, okay, and we'll talk more about that domain set, but the natural numbers, of course, is just your basic counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we also have a finite sequence, okay, infinite, finite. Some people like to say finite, just infinite, infinite, okay, but it's actually a finite sequence, okay, it's a finite sequence. And it's a function whose domain is a set of natural numbers still, only instead of going on forever, we're going to stop at a specific number. Okay, and that's the big part about the infinite sequence, goes on forever, whereas the finite sequence has a specific number of terms. Okay, a finite sequence has a specific number of terms. So it's still going to have a pattern to it. So let's say I have 1, -2, +3, -4. Well, it's got a pattern. I'm increasing by 1 and alternating negative signs. But it's not going to have a dot, dot, dot at the end because this is going to be the end. Okay, 1, -2, 3, and -4. That would be my finite sequence. So I'm only looking at those 4 particular terms. Okay, so that's what makes it finite, is that it doesn't continue on forever. We're just going to say 4 terms and we're going to stop it there. Or I could have said 6 terms and I would have had 5 and -6. That would have been my 6 terms and I would have stopped there. Okay, so that's your finite sequence. One of the big ones that we're going to work with here is the a sub n. Okay, a sub n, which represents the general term. That's super important. So the general term basically is something that has variables in it that represents the pattern that you see here. So 2, 4, 6, 8 can be represented with a pattern, basically an equation that would represent 2, 4, 6, 8. And I'll talk about how to get those a sub n's and how to use them in a little bit. But it's called the general term. Okay, so example 1 should be super easy. Find the first 3 terms of the sequence whose general term is given by a sub n is equal to n squared minus 1. Okay, so if I'm looking for the first 3 terms, first of all, make sure you read your directions closely. Know what they're asking for, know how many numbers you're supposed to give. So they want the first 3 terms in this particular sequence that has a pattern of n squared minus 1. Okay, so they want me to list out the first 3 numbers of that pattern. Very simple. To find the first term, you just use a 1 in place of n. So it's going to be a sub 1. That 1 means I'm looking at the first term. And I'm going to take my a sub n formula, so it looks like this, n squared minus 1, and I'm going to replace my n's with 1s. So I'm going to go 1 squared minus 1. Okay, 1 squared is 1, minus 1 is just 0. So my first term in this sequence would be 0. So I would do the same thing for a sub 2. 2 squared, so just replace the n with 2. So 2 squared minus 1 is 4 minus 1, which is equal to 3. Do the same thing again. I want the first 3 terms, so here's the third term. Okay, that was second. Sorry, this was third. So the third term, I used 3. 3 squared minus 1. 9 minus 1 is 8. So my first 3 terms of this sequence are going to be 0, 3, and 8. Those are the first three terms, 0, 3, and 8. Okay, so general term, this is basically an equation that represents the pattern that you see here, and these are the actual terms, 0, 3, and 8. Okay, there is it on your own. Go ahead and hit pause, see if you can get it. Should be pretty quick, should be pretty easy. I'm going to keep on going here. So they want the first 4 terms of the sequence whose general term is given by a sub n is equal to 5 plus n squared. Okay, so the first 4 terms, so just do the first 4 terms. A1 is the first, A2, A3, A4. That would be my first 4 terms. So plug in A1 for my n value. So 5 plus 1 squared. Well, 1 squared is 1, so that's 5 plus 1, which is 6. Okay, A sub 2, we're going to plug in a 2 this time. So 5 plus 2 squared. Okay, just replacing that in. So 2 squared. So we get 5 plus 4, which is 9. Okay, A sub 3, so 5 plus 3 squared. Again, this is the actual third number in the sequence. So 5 plus 3 squared, which is 5 plus 9, so that's going to be 14. And 5 plus 4 squared, which is 5 plus 16, which is going to be 21. Okay, so the first 4 terms written in order. Now, I can't write them backwards or anything like that. My first term is literally 6. Second term is 9, third term is 14, and fourth term is 21. And that is important, okay, because they have to actually follow in that exact order, otherwise your pattern's messed up. So this is your pattern, this is the order, 6, 9, 14, 21. Okay, so that's going to be the first 4 terms. Now for example 2, it's a little bit different, but it's almost the exact same thing. They give us a general term again. They tell us it's a sequence. And they want me to find the first term of the sequence. Well, if I want to find the first term, quite simple, I just put a 1 in, right? That's how I find the first term is 1. If it was the second, I would put in a 2. So first term, a sub 1, use the general term. Okay, there's my general term. We're going to plug into that. So we get negative 1 to the first power over 3 times positive 1. Okay, well, negative 1 to the first power is just negative 1, and 3 times 1 is 3. So my first one is just negative 1/3. Okay, now a sub 8. That 8 right there says this is the 8th term. Okay, that's what that little number right there tells me. It is a sub 8, so I'm looking at the 8th term. So if I were to list them all out, 1 through 8, this would be the last one. Okay, but if I want to find the 8th term, I don't have to do 1 through 7 first. I just plug in the 8. So we're going to get negative 1 to the 8th power over 3 times 8. Okay, now negative 1 to the 8th power. You got to remember that negative 1 times negative 1 would be positive 1. Times negative 1 gives me negative 1. Negative 1 times negative 1 gets me back to positive 1. So you're just going to keep rotating through 1s and negative 1s. Okay, because anytime you multiply 1 by 1, you're still going to get 1. Okay, so that negative is just going to rotate. So here's the easy way. If the exponent is even, okay, then that negative 1 is going to be negative. If the exponent is even, then it's going to be positive. I said that backwards. And then if the exponent is odd, then it's going to be negative. Okay, because if I multiply negative 1 an even number of times, like negative 1 times negative 1, that's an even number, I get a positive 1. If I multiply in an odd number, so times negative 1 again, I go back to a negative number. So negative 1 to the 8th power is positive 1. 3 times 8 is 24. Okay, so exponent is even, it's going to be positive. Exponent is odd, it's going to be negative. Now the 100th term of the sequence, again, I'm definitely not going to do 1 through 99. I'll be here all day. I can just go straight to the 100th term. So we're going to look at a of 100. Okay, so a sub 100, which is going to be negative 1 to the 100th power over 3 times 100. Okay, so negative 1 to the 100th power over 3 times 100. So that's going to give me a positive 1 over 300. So that would be my answer. Now a sub 15, we're just going to plug in. So negative 1 to the 15th power over 3 times 15. Now this is an odd exponent. Since it's an odd exponent, that's going to make that a negative 1 over 3 times 15, which is positive 45. Okay, so negative 1 over positive 45. So that would be your answer there. Okay, big thing is being careful with those negative signs. Okay, odd exponent like 1, you get a negative 15, that gives me negative. Even exponent gets me down back to a positive, so positive there and there. Alright, so that part is, there's an on your own for you to do. Okay, so please hit that pause button. Make sure you can get these 4 little on your own things right. Okay, so go ahead, hit pause, come back, see if you get the right answer. I hope you do. Okay, I'm going to go ahead with it. So the first term of the sequence, a sub 1, just plug in that 1. So negative 1 to the first power over 5 times 1. Negative 1 to the first power is just negative 1 over 5 times 1, which is 5. Okay, so for B, a sub 4, you would get negative 1 to the 4th power over 5 times 4. So negative 1 to the 4th power, that's positive, so you get 1 over 20. Okay, even exponent, positive 1. Even exponent, positive 1. So I get 1 over 20 is my answer there. Now this one, read very carefully and make sure you're very careful when you're reading these on the test. This says the 30th. Okay, the 13th would have an N in it. It's the 30th term of the sequence. So a sub 30 is negative 1 to the 30th power over 5 times 30. Okay, so even exponent, that makes that positive. 5 times 30 is just 150. Last one here, a sub 19. So I get negative 1 to the 19th power over 5 times 19. Okay, that's going to be odd, so it's going to be a negative 1 over 5 times 19, which is going to be 95. Okay, so A should be negative 1 over 95. Now those are kind of the easy part. Those are just finding terms, finding specific terms. Okay, big thing is just going to be reading instructions, making sure you know, am I supposed to be giving the first 4 terms or the 4th term? Okay, if it's the 4th term, you just plug in 4. If it's the first 4 terms, then you would plug in 1, 2, 3, and 4. Okay, so now we're going to look at writing general terms. And this sometimes can just be a matter of playing with the numbers. Okay, but the best way that I could tell you how to go about finding, basically I'm trying to find an equation that represents this pattern. Okay, I'm trying to find my a sub n, that general term, like we have up here. They want us to find one of these so that we can plug it in and get all of those numbers, and we need those numbers to be this. Now the easiest way to think about it, because it's a little different than when you did it for like Algebra 1. When you did it for Algebra 1, you just said, well, what's the difference from here to here? That'd be 3 and 5 and 7, and then you have to write an equation that way, which still works. Okay, but to me the easier way to think about it is that I'm writing in terms of n, and I know my n values. For instance, here, n is going to be 1 because it's my first term. Here, my n is going to equal 2 because it's my second term. N is 3 because it's my third term, and it's 4 because it's my 5th term. So I know my terms. So for me personally, and I hope this helps you, is that the easiest way to think of this is what is happening to my n values to give me 1, 4, 9, and 16. Well, 1 and 1 stay the same. 2 and 4, that's either times 4 or 2 squared or plus 2. Okay, but 3 to 9 is going to be squared. That's the only way to go from 3 to 9 would be to square that n value. 4 to 16 would be a squared. So these are all squared terms. Okay, and do note that I went all the way down. I don't want to just do these two, okay, because then I could be off. So I want to go all the way down and check all 4 of my numbers. I square 1, I get 1. I square 2, I get 4. I square 3, I get 9. I square 4, I get 16. So my general term is going to be that n value squared. Okay, so a sub n is equal to n squared. And you can try it. A sub 3, that should give me my third term. When I plug in 3, I get 3 squared, which is 9. And that is my third value. Okay, so that's how you can check yourself to make sure that you're doing these things correctly. Sorry, my computer screen froze yet again, as it always does on every video lesson. Okay, but that's how you can check yourself. So 3, which is my third term, I get 3 squared, which is 9. That is my third term, so I did it correctly. Okay, so that's just a check. You can leave that on there. You just need to write check over the top of it if you're going to leave it on your paper. A sub 3 is 3 squared, which equals 9. So it checks. Okay, so looking at B. Now when you see a fraction, the best way to go about looking at fractions is to look at the top first and then the bottom. So if I just look at the top here, okay, well I've got 1s going all the way across the top. Well, that's super easy. That means that on my general term, I'm going to have a 1 on top. Okay, because I'm going to have 1 over something. Now I have to see, I've got 1, 2, 3, 4, 5. It is increasing by 1, but I want you to be careful here. Because if I do n plus 1, 1 plus 1 would give me 2. That wouldn't give me a 1. I need a 1. So you have to compare. Here n is 1, n is 2, n is 3, n is 4, because that's the fourth term, n is 5, because that's the fifth term. Well, if you look at those match, right? Okay, so when n was 1, this thing was 1. When n was 2, this thing is 2. When n is 3, this thing is 3. So that means it is n on bottom. And again, we can check. So if I look at the fourth term, and it doesn't matter which term, I can use the third, the fourth, the fifth. Okay, but look at the fourth term. If I plug it in, a sub 4, I get 1 over, using my formula, I get 1 over 4. My fourth term, 1, 2, 3, 4, is 1 over 4, so I did it correctly. Okay, so a sub n is equal to 1 over n is the correct answer there. Okay, so same thing here on C. Now you have to be careful here, because it says 1, 3, 5, 7, so this thing is going up by 2, plus 2, plus 2. But if I do n plus 2, well then when I plug in 1, I would automatically get 3, so it fails on the very first number. Okay, because n is still 1 here, n is still 2 here, n is still 3 here. So I'm trying to increase by 2 each time. To increase by 2, you do 2 times n. And this confuses people, because when I'm adding 2 to each number, I'm actually doing 2 times n. Okay? But if I do 2 times n, then I would get 2, 4, 6, 8. But I want 1, 3, 5, 7. So if I subtract 1 from it, well, now I've got 2 minus 1 is 1. 6, because 2 times 2 is 4, minus 1 is 3. Okay, 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. So by removing 1, I'm doubling them, and then we are going to subtract 1 to do the 1, 3, 5, 7. But here's the important part I want you to see. Plus 2, plus 2, plus 2, we actually use times 2 in our equation. Okay? If we had plus 3, plus 3, plus 3, we would go times 3 in our equation. Plus 4, plus 4, plus 4, plus 4 would go times 4 in my equation. Okay? Same pattern over and over again, and I hope you can see that, because that'll help you. And then you can adjust by changing your number here to make that first number match up. Okay, so then here, 1 over 2, 1 over 4, 1 over 8, 1 over 16. Okay, so yet again, I'm trying to figure out what's happening. Well, I know on top it's a 1, because it's 1s all the way across. Okay, it's 1s all the way across. So 2 to 4, we added 2, okay, but we're 2 to 8 is doubling. 2, 4, 8, 16, 13, I'm doubling every time. Now that's a little different than here. If I wanted to add 2, I do 2 times n. But to get something to double, I can't do 2 times n again, because that's going to make it add 2 every time. To get it to double, we use 2 to the nth power. Okay, 2 to the nth power. Because when I do 1 here, it's just 2. If I do 2, it's 2 times 2. If I do 3, it's 2 times 2 times 2, which is 8. Okay, 2 to the 4th is 16, 2 to the 5th is 32. So when I plug in my values, that exponent is how I get it to double. If I wanted to triple, I would use 3 to the n. quadruple 4 to the n. Okay, so if you see these numbers multiplied by 3, so for instance, if I started at 2 and I went 2 times 3 is 6 times 3 is 18 times 3 is whatever it is, it keeps getting bigger and bigger. Okay, so if these numbers were being multiplied by 3, I would go 3 to the n. I know that's very hard, so adding we actually do 2 times n in the problem. If I am doubling, we do 2 to the nth power. Alright, so hit that pause button, try these. These ones are more difficult, not the on your own, but the writing the general term tends to be more difficult for people. So make sure that you are trying these, see if you can understand the concept that's happening, because that's going to make a very big difference on your test score on whether you can do these types of problems or not. Okay, so hit that pause button, come back, see if you get the same answer. Here we go on mine. So when I look at these, I know my n value here is 1, here it's 2, here it's 3, here it's 4. Well, look at those top numbers. When it's 1, it's 1. When it's 2, it's 2. It's 3, it's 3. They're the same. That means the top number is n. Don't do n plus 1 just because it increases by 1. Remember, increasing by 1, I'd multiply by 1. But I don't need to multiply by 1 because anything multiplied by 1 is just itself. Okay, so I just get n on top. When n is 1, it's 1. When n is 2, it's 2. When n is 3, it's 3. When n is 4, it's 4. So on bottom, I have a similar thing. I'm increasing by 1, only I didn't start at 1. Okay, it's 1 up from that. So when it's 1, it's 2. When it's 2, it's 3. When it's 3, it's 4. When it's 4, it's 5. So it's n plus 1. Okay, because it's bigger by 1 each time. When I plug in 1, I get 1 plus 1 is 2. Plug in 2, I get 2 plus 1 is 3. Plug in 3, I get 3 plus 1 is 4. Plug in 4, I get a 4 plus 1 is 5. Okay, so n over n plus 1 is what you should have gotten for the first one. Now the second one, I kind of already gave you a hint to it when we talked about this one. So this is going times 3. Okay, this is going to go times 3, times 3, times 3. It's multiplying by 3 each time, which means it is tripling, which means I'm going to go 3 to the n power. Okay, 3 to the n power. Notice I didn't do 1 over on this one. Here it was 1 over because I had 1s on top. Here there is no top, so it's just 3 to the nth power. Okay, so 3 to the nth would be my a sub n value here. Now they are going to throw some word problems at you occasionally, so looking at example 4, the amount of weight in pounds a puppy gains in each month of its first year is modeled by a sequence whose general term is a sub n is equal to n plus 4, that's important, where n is the number of the month. Write the first 5 terms and find how much weight the puppy should gain in its 5th month. Okay, pull out the important information, figure out what they're asking me. They actually want 2 things here. They want the first 5 terms, and they want the amount of weight the puppy should gain in its 5th month. Okay, and I say that for a reason, and I'll talk about that for a second. So, let's start by listing out our 5 terms. A sub 1 is 1 plus 4. A sub 2 is 2 plus 4. A sub 3 is 3 plus 4. A sub 4 is 4 plus 4. Yes, you have to show this work on your test and on your homework, or you don't get credit. They wanted the first 5 terms, so A sub 5 is 5 plus 4, which is 9. So then they want to know how much the puppy should gain in its 5th month. So in the 5th month, it gains 9 pounds. Okay, puppy should gain 9 pounds. Okay, so the puppy should gain 9 pounds in his 5th month. That doesn't necessarily mean he's going to gain exactly that, but he should gain 9 pounds in its 5th month. Now, what I want to kind of just point out here, because we will be doing partial sums later in this unit, so I wanted to point out here that here they wanted the 5th month. So I just gave the 9 pounds. But that doesn't mean my puppy has only gained 9 pounds after 5 months. Okay, that's a slow-growing little puppy unless it was tiny. Okay, what this means is that in the 5th month, the puppy should gain 9 pounds. But it already gained 5 pounds in the 1st month, 6 in the 2nd, 7 in the 3rd, 8 in the 4th, 9 in the 5th. So this is 9 additional pounds to whatever the puppy was born at, plus all of that weight. Okay? So this is 9 additional pounds that the puppy will gain in that 5th month. So that's kind of the difference. We're not talking about just 9 pounds total in 5 months, but 9 pounds in that 5th month. All right. Now, there isn't on your own. Go ahead and hit the pause button, see if you can figure it out. Come back, make sure you get the correct answer. Here we go. The value V in dollars of an office copier depreciates according to the sequence V sub n is equal to 3,950 times 0.8 to the nth power, where n is time in years. Find the value of the copier after 3 years. So, here, if you did 1, 2, and 3, you kind of wasted a little bit of your time because they didn't ask for what it will be after year 1 or year 2. They just want to know what it'll be after the 3 years. So we're going to jump straight to V sub 3. Now, V is just going to be the same thing as like the A has been in all the other ones. They just change variables, not a big deal. V sub 3 is 3,950 times 0.8 to the 3rd power. Now, something I do want to caution you on. When you're looking at this, order of operations says parentheses first, but parentheses means inside parentheses. Okay, there's nothing to do in my parentheses. Okay, there is multiplication here, but that's outside of parentheses. That's not the same. So parentheses first, which there's nothing to do inside my parentheses. Exponents come second. So before I multiply these two numbers, I must do 0.8 to the 3rd power, okay, and then times 3,950. Either that or I just plug it all in my calculator like this, and my calculator will naturally do order of operations. So the calculator would do 0.8 to the 3rd power, and then times 5,950. So be very careful there, that you make sure you do your exponent first and then your multiplication. When you do, you should get 2,022 and 40 cents. Okay, 2,022 and 40 cents should be your answer there. All right, that is the end of sequences. We will talk more about sequences when we hit partial sums, and as well as arithmetic and geometric sequences. Okay,